Today we have the Snapmaker 2.0. It started out as a Kickstarter campaign raising a record-breaking $7.8 million. And where did all that money go? To make this beautiful 3-in-1 modular machine capable of 3D printing, laser engraving and CNC carving. To be fair, it looks really good on paper. And we also have a special guest today, my youth. So let's see what the Snapmaker does to this. Will it snap it or make it? Welcome to Melopine Lasers. I thank Snapmaker for sending us the machine for review. Just to be clear, this video is not sponsored by them. Snapmaker 2.0 is an updated version of the Snapmaker original launched in 2017. It's a 3-in-1 CNC capable of performing 3D printing, laser engraving and CNC carving operations. The major difference between Snapmaker 2.0 and original is that 2.0 has a larger build volume, which means you can print larger objects. The printing speed is also improved and its software has been updated to make printing easier. Snapmaker 2.0 has 3 versions, the A, AT and F. You also have 3 different size options in each of these. The 350, the one I have here, has the largest build volume and lets you make things that are around 12.5 by 13.75 by 13 inches. One of the very first things that I noticed was the build quality. It has an all-metal build that is really rigid. The frames are made of anodized aluminum and all the linear motion components including the stepper motors and the driver are housed within these 30 linear modules. The rigidity of a laser or 3D printing machine does not need to be very high. Still, for a CNC you need good rigidity to handle all the vibrations and stress when the tool is pressed against the material, and the Snapmaker can handle those well. For linear motion it uses 5 stepper motors. 1 for the x-axis, 2 for y and 2 for the z-axis. The gantry uses lead screw drive on all the axes. The lead screws are paired with multiple stepper motors, which means it can handle loads without missing steps, making it really accurate. Snapmaker uses lead screws with an 8 mm pitch on the z-axis and 20 mm pitch on the x and y-axis. This is to get that tight resolution on the z-axis for 3D printing. Some people misinterpret the pitch size as the actual size of the lead screw rod, and this is not the case. The lead screws on all the 3 axes are of the same size, just the pitch varies. The pitch of a lead screw is the spacing between the threads, so if the pitch is higher, your axis will move further per turn, meaning it will be faster. But it also limits the smallest distance you can move your axis. On the Snapmaker AT and F models, the smallest distance you can move your Z-axis is 0.05 mm and on the X and Y axis it is 0.1 mm. The linear modules are covered from all the sides. Even on the front you have these metal ribbons that keep the dust and debris out. This is really important when you use it as a CNC router, which involves a lot of dust and debris. If you get the A version, the stepper drivers will be the TB67S109. The TMC drivers are more silent and faster than the TB drivers. Now about the noise levels. The Snapmaker went up to about 75 decibel when routing wood, and it maxed out at 70 decibel while cutting acrylic. While laser engraving and 3D printing, the noise is negligible. If you're setting this up in your home, you do not need to worry. You can also get their Enclosure, which lowers the noise levels by about 10 decibel. All the cables are connected to the CAN, which stands for Controller Area Network, and this is where all the cables go in and come out. The CAN is what allows Snapmaker to have different modular accessories. It has ports for add-ons and modules that allow you to simply plug in the module and start using it without worrying about configuring. Snapmaker can also detect what is plugged into it, like if you plug in the Enclosure module, the option to control the Enclosure shows up on the menu screen. Talking about the screen, you get a 5-inch touchscreen that looks like a smartphone and works like a smartphone. This is what actually controls the machine. It runs on a modified version of Android and has a 1.1 GHz quad-core CPU. With the touchscreen interface, you do not really need a computer to control the machine, and you can run jobs directly off a USB drive or send it over to the screen via Wi-Fi. That reminds me, you can connect Snapmaker 2.0 to your computer using a USB cable that comes in the kit or over Wi-Fi. The Wi-Fi connection option is better than the USB connection option. You can send files to the controller from the Luban software and later use the touchscreen to run them. However, I could not transfer files over USB. You will have to do it over Wi-Fi. Even over Wi-Fi, the device had trouble connecting to some networks, and at times it wouldn't show up on the Luban software even if both my computer and Snapmaker were on the same network. But Snapmaker is a product that receives regular updates, and I got 2 updates within 2 weeks. They quickly fix bugs so you wouldn't probably have these problems. Snapmaker uses a separate power module to power the machine, which has a similar build quality. I really like the lights on this. The way it glows and changes colors looks beautiful. It's a sturdy unit and has some protection features. Its temperature sensor optimizes the fan operation to use less power. However, this feature is only available on the AT and F versions. Talking about the versions, the AT and F models are similar in all aspects. The AT version comes with all the 3 modules and the F version only has the 3D printing module. The price difference between the two is around $500. The A version is significantly different as the lead screw on the X and Y axis have an 80 mm pitch. This means it's slower and the stepper drivers are also less efficient than those on the AT and F. The A version has all 3 modules but lacks the 3D print head cooling mechanism and the power unit fan optimization. The A version is around $460 cheaper than the AT and costs about $40 more than the F version. So if you are focused only on 3D printing, the F model is better for you. You can get the A or AT model if you need all 3 modules. The AT model is more expensive than the A but is faster and more efficient. Looking at the assembly, I was impressed by how the parts were packed and labeled. They also give you an instruction manual to help you put this together. Assembling the machine is going to take you somewhere around 3 to 4 hours if you're going at it alone. The instruction manual that comes in the kit is so detailed that I decided to not make an assembly video. Snapmaker has a modular design and you can swap the tool heads for 3D printing, laser and CNC applications. When you switch the tool head, you also need to swap the workbed, which can take a bit of time. It took me about 15 to 20 minutes to swap the tool head and the workbed. It can be a bit troublesome if you want to switch between the modules frequently. Let's look at each module in detail. First up, we'll look into the laser module. Now back to the question, did the Snapmaker snap it or make it? Luckily for me, the engraving turned out good, but there were some edge burns even after turning on overscanning in light burn, but my uke looks great now. The laser module on the Snapmaker 2.0 uses a 1.6 watt diode laser. Compared with other laser engravers, the one on the Snapmaker is really low powered. You can get a 5 watt or 10 watt one for under $500. However, I noticed that the quality of engraving on the Snapmaker is good even after being such a low powered module. The laser module uses a 450 nanometer wavelength laser beam and they give you a pair of laser safety goggles in the kit. The goggles are of extremely good quality, just like all the other parts of the machine. The module attaches to the gantry plate using 4 screws and comes with an aluminum raised bed and some silicone plugs for work holding. The bed comes in 4 parts and you need to screw them onto the frame using around 14 screws. The raised aluminum bed provides enough room under the workpiece to remove the smoke from cutting, preventing smoke stains on the underside of your material. I ran a test pattern, which is the first thing I do with any laser machine. It helps you figure out the right settings for your laser. And later on I made some stuff using the laser and the results were really good. The cut quality was good with sharp cuts. I was able to cut 2 mm ply in about 3 passes, going at 200 mm per minute. While engraving photos, the details were sharp and you can work on wood, leather, plastic, fabric, paper, non-transparent acrylic and similar materials. I engraved this design on my phone cover. I was running the job through Loban and at some point in the process, I don't know what the issue was. It could have been an issue with Loban or the controller or my Wi-Fi. Nevertheless, it burnt a hole on my phone cover. I had to switch off the laser, edit the G-code to start from the point where it stopped and run it again to complete the engraving. The engraving turned out great with good detailing, except for the fact that it now has more holes than it needs. If you want to cut and engrave on more materials much faster, Snapmaker has a 10 watt laser module option that's priced around $500. With the 10 watt module, you can work on stainless steel, anodized aluminum, stone and glass. The laser module also has a camera on the bottom side, which allows you to capture an image of your workpiece and use it as the background for creating and placing your designs. When I tried using the camera capture feature, the capturing stops midway if it captures an empty black frame. A solution that I found is to throw in random things onto the empty space on the workbed. On the software side, you have the official Loban software that you can use to prepare the design and generate G-code for your jobs. The design interface is simple and has really basic tools. However, I am a Lightburn fan and I believe Luban cannot beat the capabilities of Lightburn when it comes to working with lasers as of now. If you are someone who likes to use Lightburn for your laser projects, the Snapmaker is compatible with Lightburn, and I was able to use Lightburn to engrave the test pattern. It might take a try or two to get it to work, but you will find info on how to troubleshoot on the support page of both Lightburn and Snapmaker. The most common issue people face is that Snapmaker won't budge even if it gets connected to Lightburn, and usually this has to do with improper baud rate setting on Lightburn. Baud rate is the speed at which the software talks to the machine, so if the software doesn't speak at a speed that the machine can understand, it won't move. Setting the baud rate to 115 to 00 on Lightburn usually solves this problem. A thing to note here is that you wouldn't be able to use the camera capture feature of Snapmaker if you are using Lightburn. I searched far and wide on the internet and there was no fix for it. I also noticed that you cannot use the camera capture feature in Luban unless you connect to the Snapmaker over Wi-Fi. Now about the CNC module. Switching to the CNC module is simple. You just mount the module onto the plate on the gantry using 4 screws and connect it to the can. You also get an MDF workbed with threaded inserts, and assembling the workbed involves taking out and putting in lots of screws, around 14 of them. Snapmaker provides these good looking clamps with screws and big nuts for work holding. Once the module is connected, the controller automatically detects the module and takes you through the calibration process. The CNC module does not have the Auto Z feature, and you need to set the Z height manually using the calibration card or a piece of paper. They also included a pair of safety goggles in the kit to protect the eyes. Snapmaker also gives you 2 end mills, a 1.5 mm thick flat bit and a 1/8 inch ball end mill. The CNC module on the Snapmaker 2.0 uses a 12,000 RPM spindle and comes with an ER11 collet, which means you can use 1/8 inch bits. I was able to cut a 3 mm thick acrylic sample that came in the kit to make a phone holder in about 40 minutes. I made the cuts at 300 mm per minute and at a depth of 0.4 mm per pass. I even tried routing some softwood at 500 mm per minute and 2 mm depth of cut. There was no flexing or unwanted vibrations, but it did bog down the spindle in some places. So you can expect to go around 300 mm per minute to be on the safer side or reduce the depth of cut. On the software front, you have the Luban software that you can use to make a basic design and generate the G-code. You can use Luban to perform 4-axis CNC cutting with ease, but you will need their rotary axis upgrade. If you want to use some other software for generating the G-code, chances are that you wouldn't be able to run them on the Snapmaker unless you have the right post-processor. If you use Fusion 360 for CNC jobs, you're in luck. Snapmaker has a post-processor for Fusion 360 and you will have no trouble running G-codes from Fusion 360 on Snapmaker 2.0. I wanted to use eCell to generate the G-code for some cuts and found out that Snapmaker wouldn't read the file at all. So I ended up opening the G-code as a text file and compared it with the G-code generated on Luban. I changed the first few lines of the G-code to match with the file generated by Luban and the code worked. As a CNC, the Snapmaker 2.0 is a well-built machine with lead screws, an all-metal frame and a cast iron base. It takes on vibrations really well and is fast enough for light routing. Another interesting thing about Luban software for CNC is that you can drop in 2D images into the software and it will create a 3D relief carving model for you. 3D carving on CNC machines is a bit tricky if you don't really have the right software tools. You can do 3D relief carving using Luban even if you are a beginner. So I'll give that to Luban. Coming to the material aspects, I cut acrylic and pine wood on this CNC. Snapmaker 2.0 can cut hardwood, carbon fiber sheets and PCBs. Also with the right end mill, speed and feed, you could engrave on metals. Snapmaker is primarily built as a 3D printer with laser and CNC capabilities, and that's what it does best. The module has the same form factor as the other modules and comes with a heated workbed. It has a build volume of around 320 by 350 by 330 mm and has a layer resolution of 50 to 300 microns. You also get the auto leveling feature that helps save a lot of time spent leveling the bed manually. The nozzle can be heated to a maximum temperature of about 275 degrees Celsius and the bed can go up to 80 degrees Celsius. You can work with 1.75 mm thick PLA, PETG, wood PLA, ABS and TPU filaments as of now. As for tools, you get a knife, a tweezer and a wire cutter in the toolbox. They also give you a 1 kg spool of black PLA filament with the kit. I used it to print out a bunch of stuff. I made this 6-inch tall Eiffel Tower using the fast preset and it took me around 3 hours to print this, but the top broke off when it fell down, so I had to glue it on. Even on the fast preset, it looks good. I then used the high quality preset to print out the base model in the Luban library. It took me around 37 minutes to complete this 2-inch tall model. The model came out pretty good and strong, so I decided to print out a larger vase using custom settings, and I printed this 19 cm tall vase in about 3 hours and 15 minutes. I also printed out a 7 mm block for focusing my Comgro laser and the dimensional accuracy was good. The print quality is definitely good, but it's a slow machine and you will need to be patient with it. The heated bed takes a long time to get to the set temperature, especially if the temperature you set is above 70 degrees Celsius. I set a stopwatch and found out that it takes about 6 minutes to get to 70 from 28 degrees Celsius. On the software front, Luban software supports slicing operations and you can import STL files and slice them for 3D printing. You can perform basic operations like rotating and scaling, and you also have a ton of different options to fiddle around for 3D printing. Luban also comes with 3 preset options: fast, normal and high quality to get you going quicker. The software is really easy to use and even a beginner wouldn't find it difficult to get around. If you're looking for a 3D printer and don't want the laser and CNC module, you can go for the F version and save around $500. Snapmaker also sent us the Enclosure for the Snapmaker 2.0 for review. This is a well-designed enclosure. It comes as parts in a box with lots of well-labeled boxes within. The enclosure also has its own instruction manual which is well detailed. It even has a 1:1 scale picture of the screw you would need for each step. The instructions really make it fun to put it together. Putting this together is going to take you as long as putting together the main machine. Once complete, it's large and heavy, and you would need help to get your Snapmaker 2.0 in and out of it. It has tinted acrylic sheets on all 5 sides that blocks out the laser light and keeps the dust and debris inside while using the CNC. But this also means that light can't get in, which is why they have provided LED strips on both sides which illuminate the work area. The enclosure also has an exhaust fan and they give you around 6 feet of 3-inch exhaust duct. And to control all these features, the enclosure option shows up on the touchscreen when you connect it to the CAN module. You can control the lights and fan from the touchscreen. There are sliding doors on the front and right side of the enclosure to access the work area. These doors have hall sensors that detect whether the door is open or closed. So if you open the enclosure door while the laser runs, the controller will cut the power to the laser. This also means you cannot access the touchscreen without stopping the machine. That's why Snapmaker has provided this small window on the front with a screen stand so that the screen is always accessible. The enclosure costs about $600 for the 350 model and around $400 for the 150 model. So why do you need an enclosure? It keeps the dust contained, allows you to safely vent out fumes, prevents accidental exposure to the laser, reduces noise and protects you from debris while CNC routing. If you are using the machine in your house and have kids around, you should definitely consider getting the enclosure. Snapmaker also has an air filter that you can hook up to the exhaust fan and filter out the fumes. You can consider purchasing it if you are going to laser cut fume producing materials like synthetic leather indoors. To improve on the safety side, Snapmaker offers an emergency stop switch for around $60 on their website. So that's about it. Here is what I think. Snapmaker 2.0 is definitely an upgrade over the original Snapmaker. It can perform CNC, 3D printing and laser engraving operations. As a laser, the Snapmaker does provide good quality output, but you will need the $500 10-watt laser upgrade to be able to work with hardened materials and to get jobs done quickly. The lead screw drives on all axes mean that it will not be as fast as a belt-driven machine, but the results are going to be much more accurate. As a CNC, if you're going to work with small workpieces, Snapmaker can give you good results with good tolerances. The work area is a limitation for large workpieces, and the speed at which it can cut does not match the speed of a dedicated CNC in a similar price range. As a 3D printer, the prints are really good, the build volume is quite good, and the software package also makes it a good purchase. Overall, if you need a dedicated machine for laser cutting or CNC routing, there are better machines out there that do a better job at a similar price. But if you are a hobbyist or DIY enthusiast trying to bring your creative ideas to life, the Snapmaker 2.0 is a 3-in-1 solution for you. It takes up less space than 3 dedicated machines and lets you do most things you need for prototyping. So that's it about the Snapmaker 2.0. I'll be bringing out videos on how to make interesting stuff using lasers soon. So hit that subscribe button for some awesome content. If you want more interesting stuff on CNCs and lasers, visit mellowpine.com/CNC. Until next time.